Hello dear students, welcome to Mysore Pathshala. I am Pooja Vaishnav, your chemistry mentor, and today in this video we are going to learn about the chapter known as solution of your class 12th. So I hope you people are more excited and you want to learn this, and without making any delay, let's get started.
So let us begin with So what is solution generally mean? What is the meaning of solution? Solution itself says it is something like liquid, right? If we ask any of our non-science students, obviously he is going to say solution means any liquid substance, like juice, it can be milk or coffee, tea. What these all are? These all are obviously a solution, because to make a juice we are adding many components, like it can be a juice extract, water, sugar, right? To make a juice we used to add many different components. So after that we used to get a solution that is known as juice. Similarly, in the milk we know that there is a water and also milk components present. To make a coffee we need milk, coffee powder, sugar, and these all are what? These are the components present in the coffee. So I can call coffee is also a solution. Similarly, tea, it is made up of different components. So generally solutions is something which we come across every day, right? And if I ask you water, H2O, what it is a pure substance or a mixture? If I ask you, is it a pure substance or a mixture? You're going to say, yes, it is a pure substance, because water is pure. We are drinking pure water, right? So it belongs to pure substance. Okay. And if I add a salt to this, what I'm going to get? I'm going to get a salt solution. By adding salt to the water, I got a salt solution, and the resulting mixture what I got is a solution. So I'm calling it a salt solution. So when salt is also a pure substance, yes or no? It is also pure substance. When two pure substances are mixed, I got the mixture. Yes. So what is the meaning of solution? You can see the definition here. It is a homogeneous mixture of two or more substances. So two or more substances added. Yes, even here we saw two substances added. Even in making juice we added many more substances like juice extract, water, sugar. And similarly in case of coffee, tea, we have added many substances. More than two substances are added, right? Two or more than two substances are added to make a solution. So what is the meaning of homogeneous mixture? Homo means same. Geneous means composition. So when two components or two substances are added, we get a homogeneous mixture. Correct? Okay. When two or more substances are mixed, we get a mixture. And after mixing, if we are getting a homogeneous mixture after adding a components or a substance, if we are getting a homogeneous mixture, then that particular mixture is known as solution. So as I told, what is homogeneous means? It is a uniform or same complete composition. So what is the meaning of that? Let us understand that. Consider a glass of water. To that I have added a small spoon of salt. And after adding salt, I got a salt solution. And can I separate the salt and water now by any physical method, like by filtration, right? Can I get it? No. A spoon of salt, I can't able to get it back by physical methods, right? And after adding a salt to a water, I can see it is completely uniform. The composition of that water salt solution is completely uniform. I cannot say that only in one particular place only salt is present and in one particular place only water is present. Correct? So again, when the two components are mixed, and after mixing the components, the mixture which I am getting is uniform. If it is uniform, then I can call it as a solution. Clear? And it cannot be separated by any physical methods. So there are many examples which we have seen in our everyday life. Yes. So let us move on to the components. In the solution, what are the components present? So here we can see a solution containing only one solute dissolved in a solvent is called binary solution. This is important. Bi means two. Bi means two. When only two components are mixed, and if I got a solution, then that particular solution is known as binary solution. Then obviously in that two components, one is going to be a solute and one more is going to be a solvent, because the solution is consist of two components or more than two components, but the main two components present are solute and solvent. So here in this salt solution we have solute and solvent. So which is solute and which is solvent? That is the question. So solute is a one which present in a smaller quantity, and solvent is the one which is present in larger quantity. So obviously I can say that salt is a one which present in a smaller quantity. So which is solute here? Salt is a solute. And water is present in larger quantity because a glass of water, right? And it's a spoon of salt. If we compare the quantity, obviously water is more compared to salt. So which is present in larger quantity? Water is present in larger quantity. So the solvent here is water. So can I call this salt solution as a binary solution? Yes, because only two components are present. So this salt solution is called as a binary solution. Binary solution. Now you are clear what is the meaning of binary solution. If only one solute and if only one solvent is present in a solution, then such solution is known as binary solution. Then if I ask you what is trinary or ternary solution, if I ask you, what you are going to say? Ternary solution means three components. If a solution is having three components, then it is called as a ternary solution. Okay. So let us move on to next, characteristics of solution. Let us see what are the characteristics. So the solution consists of only one phase only. As I told, after mixing, I should not see the layers or any phases over there. I should have a uniform, only one single phase. In example, salt water. When salt and water are mixed, I got the salt solution and there is no layers or there is no phases I see. So it is obviously a solution. So what they want to say is the solution consists of only one phase. all the non-reacting gases mix together and form a homogeneous solution. Okay. So one more question here arises. Does the solution exist only in liquid form? The answer is no. The solution can exist in liquid, solid and gaseous form also. So there are many examples we are going to study in this chapter further. So it is clear that we are not having just a liquid solution, we are also having solid solution and gaseous solution. Okay, so when non-reacting gases mix together, they give a homogeneous solution. Two or more solid do not form homogeneous solution, but many alloys such as steel, brass are the homogeneous. So example for solid solution they have given. Steel. It is obviously a mixture of many metals, right? Steel is a mixture of metals. So when two or more than two elements or metals are mixed, I got a steel. So steel can be example for solution then. Yes, it can be a solution. It's an example for solid solution. Similarly, brass, it is also a mixture of two metals, so it is also example for solution because it is a homogeneous mixture. Composition of solution may change within certain limit. Solution show properties of its component. Okay, solutions shows the properties of their components. Obviously, salt is different. It has different property. Water is having different property. And when I got the salt solution, both the properties are shown in that salt solution. So we can say that the properties of the components are shown even in the solution. Okay. Substance present in smaller amount is called solute, and the substance present in larger proportion is called solvent, as I told you. In case of solid liquid type of solution, solid is always considered as solute. If I have a solid liquid type of solution, the solid is always considered as a solute. I will explain you later in the example part. Okay. In solutions, particles are of molecular size. In the solutions, the particles are very small and they are of molecular size. The different components of solution cannot be separated by filtration or centrifugation. Okay. So let us understand the importance of solution. Okay. So brass is an example of a solution. Solid solution. Brass, have you seen brass? Yes. Brass, you might have seen. Okay. So brass is a mixture of metal. What are those metals? Copper and zinc. When these two metals are mixed, I got a brass. So after mixing this, I used to get a homogeneous mixture. Similarly, German silver is a homogeneous mixture of copper, zinc and nickel. So when these three metals are mixed, I got a German silver. When bronze is those of copper and tin. When copper and tin are mixed, I got a new homogeneous mixture, that is a bronze. So the example for solid solution are brass, German silver and bronze. All three are the example for solid solution because two solids or two metals are mixed. Here in the brass case, copper and zinc are mixed and I got a homogeneous mixture, that is brass. And when copper, zinc and one more metal, nickel, is mixed, I got a German silver. And when copper and tin is mixed, I got a bronze. They have different properties and are used for different purposes. All of this metal, what I got, all of this solution is exhibiting a different purpose of usage. Okay, so 1 ppm. Here some of the important facts they have told. 1 ppm of fluoride ion in a water prevents tooth decay. So you might know that in a toothpaste we have a fluoride component, right? So if we are using a fluoride in 1 ppm of concentration, then it prevents our tooth decaying of tooth. It can be prevented by usage of 1 ppm of fluoride. So you may ask, what is this 1 ppm? So 1 ppm we are going to learn, it's a parts per million. It is a concentration term. In this chapter itself we are going to learn what is the meaning of 1 ppm. Okay, so as of now just remember the ppm means parts per million. Okay, 1 ppm of fluoride is used for the prevention of tooth decay, but 1.5 ppm can cause teeth to become mottled and colored. If we are using more than 1 ppm, that is 1.5 ppm, it can affect our teeth and it can become colored, like somewhat molded. Okay, and still higher concentration may be used as a poison. And if we are using more than 1.5 ppm of fluoride, then it can be a poisonous for us. Okay, example, sodium fluoride solution is used as a rat poison. In the sodium fluoride, obviously fluoride is there, right? And this sodium fluoride is used as a rat poison. So you can compare the concentration. When 1 ppm of fluoride is used, it is good for the prevention of tooth decay. When 1.5 is used, it affected our teeth and it can damage our teeth, right? And if more than 1.5, if it is more than 1.5, like 2 ppm or 4 ppm is used, it is poisonous for us, and we can see the fluoride is used as a rat poison. So concentration is very important. Concentration is very important. To what concentration we are using that particular chemical, right? So obviously when we study about solution, we need to study about concentration terms. So now let us move on. One more point is given. Intravenous injection are aqueous solution of required salts. Their ionic concentration is same as that of blood plasma. Okay, so this is about infection they are told. Then let us move on to types of solution, and this types of solution are classified as 3 more types, that is gaseous solution, liquid solution, solid solution. Okay, so we have 3 types: gaseous solution, liquid solution and solid solution. Okay, so we know that solution has 2 important components. What are those? Solute and solvent. Solute and solvent. So solute is one which is present in smaller quantity and solvent is a one which present in a larger quantity. Yes, okay. So if I want a gaseous solution, that solution should be in gaseous. After mixing solute and solvent, I should get a solution in a gaseous form. So one important point you have to remember is, let us take an example. See, to prepare a salt water, what we made? We used salt, which is solid, and water, which is liquid. Correct? And when I got a salt solution, it is again a liquid form. Salt solution is also in liquid form. So I can say that the physical state of a solution is determined by solvent. Yes, because salt was a solute because it is in smaller quantity and this is in larger quantity. So So I can say that solvent determines the physical state of solution. Yes. So what I have to do when I want gaseous solution? Obviously, I have to keep a solvent gas always. I can change the solute. It can be solid, it can be liquid, it can be gas. Correct? So I want a gaseous solution means the solution should be in a gaseous state. To keep it a gaseous state, I should use a solvent that should also be in a gaseous form. Yes. So here solvent is in gaseous form. Let us change the solvents. So here we can see, let us rub this part. Okay. Just responding slowly. Okay. So solvent is kept as gas. And I have changed, not I have, it is changed. Solute can be changed as gas, liquid and solid. Now I want you to give examples for this. Gas, the solute is also gas and solvent is also gas. The best example which we see in our environment is air. Air is the best example for gaseous solution because it is homogeneous. You can say why it is homogeneous, because air is a mixture of many gases and it is completely uniform. It is completely uniform throughout our universe, right? Air is completely uniform. So it is obviously an example for gaseous solution in which solute and solvent both are in gaseous form. So air can be example for this, gas plus gas. And here they have given all non-reacting gases mixed together. Air is a mixture of, so example is air for gas plus gas or a gaseous solution. Then liquid plus gas. What we have to keep in mind is solvent is present in larger quantity. So consider any gas in that liquid component is present in smaller quantity. So what you can think of is liquid in gas, humidity in air. Obviously, if you go to a morning walk, you can see if it already rained, okay, previously it is rain and there is a air, okay, and you can feel that humidity, right? That water, small water particles are present in the air. So obviously that can be example for this case, liquid in gas. Yes. So humidity in air. And one more example given here is CHCl3 vapor mixed with nitrogen gas. This is chloroform. Chloroform is a chemical which vaporizes when mixed with N2. So we can say again liquid in gas. So nitrogen is a gas and chloroform generally in a room temperature it exists in a liquid form. But when it is mixed with nitrogen, it converts into gaseous solution. So these are the two examples you can remember. Then solid plus gas. The best example is camphor vapor in nitrogen gas. Camphor, we use it, right, for pujas and all. Camphor is generally used in all the Hindus' houses and many more places, obviously. So camphor is a solid. It vaporizes when it is mixed with nitrogen gas. So again, camphor vapor in nitrogen gas can be example for solid in gas. And one more example, iodine vapor in air. Iodine, where do you see iodine? Can think of it? Yes. In salt, common salt, what we are using for our food, iodine is present, right? So this iodine easily vaporizes. You might have seen that if a salt is kept open for few hours, few more hours, like you can see the change of color of a salt when it's kept open. It becomes little brownish. The white crystals of salt converts into brownish type. So what is the reason behind? Because in the salt also, that packets are generally filled with iodine, and when it is kept open, it completely vaporizes into air, and so we can say that iodine is a kind of solid which completely vaporizes easily. Okay, so iodine vapor in air is going to be example for solid in gas. Let us see liquid solution. So in the liquid, we are keeping liquid solvents and we are changing gas, liquid and solid of solute. So let us see gas in liquid. So just close your eyes and try to find the example for this. You may see that aquatic life, even we need air, we need oxygen to live, right? Similarly, the aquatic species also need oxygen. So how do they take? Obviously, even they want oxygen. So they used to take that oxygen from the water. If they want to take the oxygen from the water, obviously oxygen should be present in the water. Yes. So dissolved oxygen in water can be example for this, because oxygen is a gas which is present in water. So oxygen dissolved in water is the example for liquid solution. Aerated drinks. Aerated drinks means the cold drinks which we are using. Okay. Or we can say some of our spray paints, okay, perfumes. All this can be example for this, because in the drinks we know that, consider a Coca-Cola. Okay, consider any cold drink. In that, if we open its lid, obviously the bubbles used to come out, right? So what's the reason behind this? What's the reason behind this? Because some gas is present inside the liquid. Obviously, if you don't know that carbon dioxide is the gas which is pressurized inside the cold drink, so that when we open it forms a bubbles over there. Okay, so aerated drinks, then carbon dioxide is a gas which is present in the liquid. So aerated drink can be example for gas in liquid solution. Okay, so let us move on to liquid plus liquid. Liquid plus liquid, if you close your eyes, you can see many examples like tea, coffee, juice. All these are examples for liquid solution, and also alcohol and water. So these are the examples for liquid and liquid solution. So here they have given a solution of ethanol and water, acetic acid and water, acetone and water. Let us move on to solid solution. So here we are taking gas, liquid and solid as solute, and solid as a solvent, because solvent decides the physical state of solution. Okay, so now let us see some of example. Gas in solid. Gas should present in the solid. So here we have example, dissolved gases in minerals. In the minerals, the gases are present in a dissolved form. That can be example. One more, hydrogen in palladium. Hydrogen is a gas which is present, which is absorbed by the palladium metal. So palladium is a type of metal which absorbs the hydrogen gas. Okay. So obviously this can be example for gas in solid. Liquid in solid. So mercury. Mercury is the only metal which exist in liquid form. You know that. So mercury, when it is mixed with other metals like sodium, it forms an amalgam. Okay, it forms a amalgam which is in solid form. So amalgam of mercury with sodium can be the example for solid solution. Or here we have some more examples. Solution of zinc in mercury. It is a zinc amalgam. So you can say we have any metal amalgam. Sodium amalgam or a zinc amalgam can be example for solid solution. So now let us see the last one, solid and solid. Solid plus solid. So any solid and solid, just now we saw in the previous sheet examples: brass, bronze, German silver. These are all the examples for solid solution, because all of the metals which are mixed to form a solid solution were also in the solid form. So here we have example: copper dissolved in gold. So you might have seen that the jewelry, gold jewelry, they are not made up of completely 100% pure gold. It is impure gold. Impure, it means some other metal is also added to the gold to make it top. Okay, to make it strong, they used to use other metals, like it can be copper, it can be zinc, any other metals or silver is used and mixed with it to give a uniform solution. So copper dissolved in gold is an example for solid solutions. So till here you have understood what is solute, what is solvent, what is solution, what are the different types of solutions. Clear? So once again they have given what is the meaning of binary solution. Binary means two components should be present. Sugar in water can be example. If they ask what is ternary solution, three components. Sugar in water, methanol and ethanol, these are the example for ternary solution. When solvent is water, it is called aqueous solution. Yeah, this is one more point. When we are using solvent as a water, we call that particular solution as a aqueous solution. Aqueous solution. Aqueous solution. When benzene, chloroform, ethanol, etc. are a solvent, it is called non-aqueous solution. So other than water, solvent can be used. See, in the salt water, we use solvent as a water, but even in place of that, we can use any other solvent. It can be benzene, chloroform or ethanol can be used as a solvent. So if such a kind of solvents other than water are used, then they are called as non-aqueous solutions. Okay. So till now we have understood the components and all. Let us move on to know about liquid solution. Okay. Liquid solution. In such solution, liquid is solvent and solute may be solid, liquid or gas. Oxygen dissolved in water and permits the survival of aquatic life in river, lakes, oceans. A solution of ammonia in water used as cleaning solution in homes. So ammonia in water is used as a cleaning solution at our home. Liquid which mix with each other is called miscible, and those liquids which do not mix with each other are immiscible. So here we got two more things, miscible and immiscible. Miscible means if they mix up completely. So salt plus water, when I mix these two, they mixed up completely. There is no layers over there. So it is miscible. Miscible solution or miscible liquids, we can say. Similarly, if I use oil and water, if I use oil and water and mix together, is that solution is going to become miscible? No, I can see the layers. You can see the layers like this. At the top I can see the oil and at the bottom water. So I can see two layers over there. So it is not at all miscible. So we can call it as immiscible. So few more example given here is water and chloroform, water and benzene. Okay, so these are the examples of immiscible liquids. So now let us move on to solid solution. So alloy is a homogeneous and form solid solution. Brass, steel, ionic solids such as NaCl, KCl form solid solution together. H2 gas dissolved in platinum and palladium form a solid solution. So the same thing which I explained there, it is explained here. Okay. One more point about this one, liquid solution. In solution, components have greater disorder as compared to pure component. During the formation of solution, for components having molecules of nearly equal size, the entropy factor disorder favors the formation of solution. The solubility depends on the strength of interaction between the molecules of different components. Suppose EAA and EABB are the interaction energies between the pure components A and B of the solution respectively. EAB is the interaction energy between a molecule A and B. The factor determines whether the two components are miscible, partially miscible or immiscible. Greater the interaction between the molecules of a component, greater is the solubility. Simple thing. So solubility of two components. Consider once again, let us take sugar and water. Okay, so here consider I have a sugar here. In this sugar I can see the particles interaction is there. Obviously the interaction between the particles of sugar is obviously there. Similarly in the water also the interaction between the water molecules is there. But if the interaction of sugar and water particles is equal, when they are mixed, sugar water and interaction is also more, then the solubility is more. So higher the interaction, higher the solubility. Yes, so we can say greater the interaction between the molecules of component, greater is the solubility. Water and ethanol molecules interact strongly with each other, leading to complete miscibility. Water and benzene interact weakly with the resulting that benzene have low solubility in water. So this is one example given for solubility, or we can say miscibility and immiscibility. So when ethanol and water are mixed, they are completely miscible. Okay, but similarly in case of water and benzene, when they are mixed, their interaction is not that much stronger. When there is no strong interaction, obviously lesser solubility.